All right, guys, so we're going to continue our trig, TOA, trying to find some angles, and it's continuing from when we found sides of right triangles. So let's jump back into it. A brief little review. Remember, whatever angle you are dealing with, sometimes theta is the variable used, you can set up these ratios based on the sides of the right triangle. So we have the hypotenuse, of course. If the theta is up here, okay, the opposite side would be the one all the way through, other side of the triangle. And then that leaves the close side, the side that forms the angle, called the adjacent. And from SOH, a review, we know that sine, so is S over O over H, so opposite over hypotenuse. Cosine, the CAH, cosine is A over H, adjacent over hypotenuse. And then tangent, the TOA, right, O over A, so opposite over adjacent. And again, these opposite, adjacent, hypotenuses, those are the lengths of the sides. And what we did in the previous section was we would know both side lengths, and we could set up an equation, and then we could use our calculator, and we could find the, we knew the angle. I'm getting ahead of myself. We knew the angle measure, and we knew one of these two sides, and we could solve an equation to find the missing side. What we're going to do today is find the unknown angle measures. Okay, that's the variable now. We don't know the angle measure, but we will know at least two sides in the triangle. Okay, so let's look at a couple quick examples. You'll definitely need a calculator and make sure we are in degree mode again. So here's a sample problem. Let's say we want to find a missing angle. So let's pretend our theta, or they might mark an X there, or a question mark like this problem is there. So based on that reference angle, the hypotenuse, of course, you can always label across from the right angle. So the 8 is actually the opposite side, and the 22 then is the adjacent side. So we need to ask ourselves, if we're dealing with opposite and adjacent, right, because the hypotenuse isn't even involved in this problem. Sometimes you'll know all three sides, but sometimes you'll only know two. So the one ratio that deals with opposite and adjacent is tangent. So I want to see you guys setting up the equation. The tangent of some unknown angle, okay, we don't know the angle, will equal, and make sure the order is right, opposite over adjacent. Okay, and what we need to do is we need to solve this for theta. So what you're going to do, we need to get rid of tangent. Okay, and this is not like something, it's not tangent times theta. We can't divide by tangent because we don't know the angle anyways. But what you can do, there's an inverse function on your calculator. Inverse looks like a little -1 exponent. And we can take the inverse tangent of both sides. And what ends up happening is that inverse tangent cancels out tangent. So you're just left with theta equals tangent inverse of 8 over 22. And that's what you're going to do on your calculators. If you look on, it's probably right above the tangent button, you'll see a little tangent -1. On the graphing calculators, that means you have to press second tangent. And then you're just going to put 8 divided by 22 in there. And as long as you're in degree mode, we should see this is about 19.98. Okay, and that is the degree measurement of the angle. Okay, and if it rounded to the nearest tenth, like the directions usually say, we could write that as 20.0 degrees. Okay. So let's one more. Okay, let's say we have this figure here. We need to find an angle measure. Again, here's our unknown angle. So from that angle of reference, the 24 is the opposite side. It's all the way through the triangle. And the 34, okay, it's across from the 90-degree angle, so it is the hypotenuse. So we're going to ask ourselves which ratio deals with opposite and hypotenuse. Okay, and we know that is the sine. So the sine of some unknown, remember theta is just a variable for an angle usually, and do it in the right order. It's opposite over hypotenuse. And we're just going to do the same thing. We are going to take the inverse sine of both sides. Okay, sine of -1. And we're going to have that theta then must equal the inverse sine. And you're just going to put this in like a division problem on the calculator. 24 divided by 34. Okay, and that should give you your answer. So let's see what we do. Second sine, 24 divided by 34. Oops, I think I did a typo. Let me retype that real quick. And I'm getting around 44.9 degrees. Okay, so that's the measure of that angle there. And that's how that works. That's called using the inverse trig functions. Again, because we're undoing sine, right? We wanted to get basically, we want theta by itself. So doing this inverse sine here undoes that, okay? They are inverses, they undo each other. And that's all there is to that. All right.